Assalamualaikum and greetings. My name is Muhammad Shafi bin Ismail and I'm going to present about my research project which has the title of An Overview on Vitamin C Content in Dried Pineapple from Infrared Dryer. So without further ado, let's start with the presentation and enjoy my presentation. Pineapples or Ananas communis almeril are best known as one of the leading commercial tropical fruits throughout the globe. In Malaysia, back to 1888, the pineapple industry has been found to be one of the oldest agro-based export-oriented industry. As the positive growth of the pineapple industries in Malaysia with the addition of various forms of incentive by the government, pineapple skin waste issues have been raised to be concerned with the solid waste generated by the pineapple industries. Several initiatives have been developed by the researchers in consideration of better utilization of parts of the pineapple to conserve the nutritional contents of the pineapple, especially the pineapple is well known to be rich in vitamin C. In this case, the influence of using infrared drying for the drying process will be studied as one of the measures in considering the preservation of vitamin C content in pineapple skin after drying process. This has led to the main objective of analyzing the drying rate of using infrared dryer as a drying method of preservation with other type of drying besides the effect of using infrared dryer towards the ascorbic contents of the pineapple skin. Okay, moving on to the crucial part. For the first factor to be analyzed is through the moisture removal. Infrared drying has been found in the previous studies to bring some benefits towards the drying rate and energy preservation. So the comparison has been made significantly with solar and hot air drying, which commonly conducted in oven drying. And based on the previous studies, the results are compared for this particular study in order to analyze the effect of the utilization of infrared drying technology on the drying rates as compared with the traditional and current convective drying technologies. So the figure as we can see shows the comparison of drying technologies that include infrared drying, hot air drying, and solar drying as mentioned. So the comparison takes consideration on the moisture removal of the pineapple skin over a period of times. It can be said that the moisture content left after infrared drying has been almost identical value, with a little shorter time taken for air drying compared to hot air drying. So the traditional solar drying shows fewer moisture removal when the final moisture content left was only found as the highest. Okay, during the drying process, infrared wave delivers heat emitted by the infrared heating element to be uniformly absorbed by the objects, unlike convective and traditional drying method, where some energy is spent to emit the heat to the surrounding air, which spread across the area of the drying process. In other words, the infrared dryers can save time and energy due to their quick drying act, which is directly emitted by the infrared panels to the pineapple skin. And few limitations found in the study where the distance of the pineapple skin sample with the infrared panel is rarely being considered in order for the wave and the heat energy to be transmitted accordingly to the samples. The thickness of the samples are not being focused for most of the studies, although various other studies had mentioned that infrared drying technology very much depends on the thickness of the samples. It may seem complicated for the design and the mechanical procedure for the infrared dryer. However, if the design is to be proper and top planning, the energy consumption will be reduced remarkably and this will reduce the cost spent for the drying process to be conducted in a long journey of period. Next, as for the vitamin C retention as post-drying results, similarly, the comparison has been made significantly with solar and hot air, which can be viewed through the chart. That takes consideration on the temperatures variations of the pineapple skin over a period of time. It can be concluded from the studies discussed that the vitamin C retention as post-drying can be suitable with the presence of infrared drying technologies. The degradation of vitamin C can be seen to be at the lowest rate when the pineapples are dried under infrared dryer, the rate followed by the solar drying and hot air drying. So the hot air drying can be said to have the highest rate even at the 4 hours of drying. For this section, limitation is analyzed and the investigation conducted were all limited only to the flesh of the pineapples, since the skin part of the pineapples are yet to have deep investigations. And from the studies, the results obtained have proved the conclusion that the gradation of vitamin C are influenced by the drying time and the temperatures as a result of the drying process. Okay, based on the results from the previous studies, it can be seen that the degradation of vitamin C can be seen to be slow rate through infrared technologies are due to the drying behavior of the technologies where the radiation directly penetrates the samples of the pineapples efficiently in order to raise the temperature of the samples without causing much effects on the contents of vitamin C. The solar drying has major degradation distributed by the solar radiation and surrounded air hygienic issue, this causing the degradation of vitamin C to be mostly occurred. While for hot air drying, the degradation of vitamin C can be found to be happen due to the surrounding air that supplies heat to the samples react with the thermally sensitive vitamin C behavior. Hot air drying requires high temperature for the drying process and not suitable for the vitamin C retention of the pineapple skin. Okay, from the studies, temperature has been found to be one of the most crucial parameters to be controlled while conducting the drying process, especially for the preservation of pineapple through infrared technology of drying. The effect of temperature can be represented by the moisture removal of the pineapple skin. The temperature in the same way also shall be controlled with the effect on the degradation of vitamin C content of the pineapple skin. In the same time, the power of infrared radiation also may affect both mentioned resulting parameters. High infrared intensity may lead to higher heat absorption that can be resulted through higher product temperature, faster drying rate, and thus lowered drying time. Not only that, the infrared technology availability has contributed on giving a better product quality once the drying process had been conducted. Optimum intensity of the infrared radiation with moderate temperature of drying process can improve drying kinetics through its rate, besides can prevent major vitamin C degradation. Other than that, other parameter to be considered is the drying environment for the process. It can be acknowledged that vacuum condition is one of the advanced mechanisms to be considered for the drying process under infrared technologies, with the benefits of drying time reduction, lower drying temperature, and better retention of vitamin C as post-drying results. The reduction in drying time brings along with the benefits of higher drying rate with lower time for the pineapple samples to be exposed to high thermal materials that will further degrade the vitamin C contents of the samples. Drying time also plays a role for the utilization of the infrared drying technologies. From the studies, it has been found that drying time should be as low as possible for the pineapple skins to be exposed to the heating element, and thus the nutritional valuability of the skins can be preserved, and the process can be considered as time saving to conduct the process. The longer time of exposed pineapple skin to the heating materials is not suitable for water soluble and thermosensitive vitamin C behavior. Okay, in a nutshell, for this research that based on the previous studies, the infrared drying process can be an initiative in food processing. Infrared can transfer or ramp up the heat much faster and ultimately allow for the eventual turndown of the convection oven. And the increase in infrared power causes a rapid increase in the product temperature of the product, and thus increases the vapor's pressure inside the product, resulting in faster drying. Suitable process condition and proper mechanical techniques can be applied for the drying process under the infrared drying technologies after considering all the multiple benefits can be brought by the system. All in all, this research can mark on the positive impacts of using infrared dryers as an alternative of the drying process of the pineapple skin in order to prevent major degradation of vitamin C content, besides high drying rate can be achieved. As for recommendations, it is recommended to undergo more studies on the pineapple skins as the study regarding the pineapple skin is still low. Therefore, a perception of the pineapple skin can be diverted to realize that the ungrateful waste of pineapple skin may actually bring benefits not only towards humans' health but also in economical view if the processing of the pineapple skins can be developed. The upcoming studies may focus on the mechanical aspect of the drying process of the pineapple skin by infrared drying technologies, since there are numerous studies have proven that significant effects on infrared dries towards vitamin C preservation as post-drying process. So with that, thank you for listening of my video. So with that, thank you for listening to my video regarding the infrared technologies on the pineapple skin drying process.